Hi, I'm Oriol and I'll present you our work on integrating temporal context into visual language models. The proposed method is applicable to any problem, but we focus on cloth folding due to the challenge in perceiving an object with nearly infinite degrees of freedom. Let's say we have the current configuration and we try using a VLM-based policy to grasp the right leg opening given the current observation. It's clear that in this crumpled state, identifying a given part of this sponge is almost impossible. But what if we consider a temporal context? In this case, the model can learn to trace back the instruction to a configuration in which semantic parts are easily identified. As a result, the policy can predict more informed actions. In this workshop paper, we analyze BiFold, a model that we presented at the main conference. In the BiFold paper, we introduce a model, a scalable annotation pipeline, and a new dataset, but here we only focus on the modeling part. BiFold adapts the cyclic model using LoRa and encodes both the current observation and the previous keyframes using the same network. The obtained features are then concatenated, and we add positional and modality encodings before feeding them to a transformer encoder. The output tokens corresponding to the current observation are processed with convolutional decoders which yield heat maps on the observation space. First, we take the BiFold ablation in which its version without context is compared, and add another version where the context is composed of previous frames. We see that using redundant images can be detrimental due to increased susceptibility to noise and compute being allocated to uninformative tokens. Hence, the key is to use keyframes. Now, we design experiments to test whether our hypothesis is correct. To do that, we first reduce the feature dimension to 3 with PCA, discard all tokens for which the first component is negative, and perform PCA again, similar to Dynavi2. We can see how the distribution of features in cyclic changes across keyframes, while BiFold features, mostly focus on the Carmen, remain consistent and allow to easily match semantic parts such as the sleeves and the trunk of the shirt. By performing parameter-efficient fine-tuning, in this case LoRa, BiFold refines the visual representations to focus on task-specific information while preserving the robustness and open vocabulary capabilities of the pre-trained features. We go deeper into the model and take a look at how do the visual tokens interact with a fixed language token. We take keywords such as bottom and fold and see that not only do the attention maps focus on the semantically relevant parts, but they also do so consistently across keyframes. Therefore, we have further evidence that keyframes enable recognition of complex states through implicit matching. In this paper, we revisited the BiFold model and provided additional experiments to contrast two claims: that parameter-efficient fine-tuning achieves more task-specific features while retaining their generalizability, and that the history of previous keyframes allows recognizing complex object states. Please check our paper and website for more details.